Okay, guys, let's solve some triangles using the law of sines. I already have several videos on this, but I noticed for my IM3 class, I hadn't officially done it myself for IM3. I did it for IM2, and of course, on top of that, I did it multiple times as well. I think in Mr. Collier's classroom. Remember, I'm part of Mr. Collier's classroom, just to see what he's doing. But anyways, I clicked on Start. We're going to get 4 questions on the law of sines. Now, the first question, they want us to find angle A down here. Now, guys, the law of sines is not that difficult to learn. Why do we have to learn it? Because this triangle is not a right triangle. You see, if it's not a right triangle, guys, you can't do SOHCAHTOA, okay? If it's not a right triangle, you can't do Pythagorean theorem. Your only choice is to learn the law of sines. So, how do we find angle A? Is notice it's opposite of the 11. Does everyone agree they're opposites of each other? So, the law of sines says take the opposite side with the sine of its opposite angle. And that's always going to equal any other side with its opposite angle. So, notice in our case, we have a 25-degree angle. Opposite with it is the 5. So, I know that 5 goes with the sine of 25 degrees. And notice I have a proportion I can solve. So here we go. I'm going to cross multiply. 11 times the sine of 25 degrees equals, going this way, 5 times the sine of A. And does everyone agree, once I divide both sides by 5, I now have the sine of A equal to whatever that is. So let's do that on the calculator. Now guys, see the show calculator button? You have a choice. You can click on that and use the computer calculator, which is worth the practice even though it's clunkier, or you can use your own calculator. I'll let you decide on your own. The important thing is you're practicing with a calculator, getting better with doing trig functions and stuff. Okay? But anyways, I'm going to do 11 times the sine of 25. Right there and right there. There's our answer. Right? Now what? I'm going to divide that answer by 5. So guys, see how I divided by 5 and got that? See here, this by the way, if you can't tell, is my regular calculator. See how I'm doing the same? I'm doing the same work, guys. Just see that they work the same. 0.929, right? So, we just figured out the sine of A is 0.929. That's not the answer, though, because we want A. How we're going to get A, guys, is we're going to do the sine inverse on both sides. See, sine inverse gets rid of sine, and in this case, I'm left with A. A is going to equal what? Well, let's do the sine inverse. So guys, on this calculator on the computer, you have a sine inverse button. On most calculators, you have to do second or shift sine to get sine inverse, right? Don't forget that. And when I do sine inverse of our answer, I get this. Now, the computerized calculator shows it weird, guys. Sine inverse is shown as A sine, short for arcsine. It's just another name for sine inverse. Okay? But anyways, sine inverse of the answer is this. Rounding off to the nearest degree, we know that A is 68 degrees. And you're going to type it right in there, and you're going to get credit for it, right? All right, let's do another one. This time we're asked for missing side AC. I'm going to call it little x, okay? You can call it any letter you want. You can even call it AC if you wanted. But anyways, I know that little x, do you guys agree, is opposite with the 71-degree angle. So little x is going to go with the sine of its opposite angle, 71 degrees. That's got to equal, notice the 7 here is opposite with the 23-degree angle A. So I know that 7 goes with the sine of 23 degrees. Let's solve it. Going this way, I'm going to do 7 times the sine of 71 degrees. Going this way, cross multiplying, x times the sine of 23 degrees. And all I'm going to do next is I'm going to divide both sides by sine of 23 degrees, because that gets rid of sine 23, and I have x. So what's cool about this one, guys, once I do all of that work, it's one less step on the calculator to get the answer. So let's do it. Let's do 7 times the sine of 71. 7 times the sine of 71, right? See how I got the same answers again? Let's divide by the sine of 23. Take the answer, divide sine 23. Take the answer. I'm just showing you on both calculators. You get the same result, basically. Bam, bam. Now, guys, they wanted you to round off to the nearest tenth. So that means we're going to round off to 16.9. 16.9. That's our answer, right? 16.9. All right, let's do one more. This time we're missing angle C. It is opposite with the 7. So I know 7 goes with its opposite angle, the sine of its opposite angle, which is C. Notice the 6 is opposite of the 47. See how they're across from each other, guys? Opposite, right? So 6 goes with the sine of 47 degrees. All right, let's cross multiply. 7 times the sine of 47 has to equal 6 times the sine of angle C. We got to, of course, divide both sides by 6. So now we have the sine of C equal to whatever that is. So let's do it on the calculator. 7 times the sine of 47. 7 times the sine of 47, 5.11, right? We're going to divide it by 6. Divided by 6, 0.8532. So the sine of C is 0.8532. Now wait a minute. That's not the answer yet. We want C. What are we going to do, guys? That's right. We're going to do sine inverse. Sine inverse gets rid of my sine. So I know C is equal to this. So let's do it. I'm going to look over here, guys. I'm going to do arc sine, which we refer to as sine inverse. That's the button on this calculator. It's shift or second sign on a regular calculator, right? But anyway, sine inverse of our answer here is this. And they want us to round off to the nearest degree, so that 5 means I'm going to round this answer off to 59 degrees, right? 59 degrees. Okay, guys, so you have at least 1 or 2 more to do. And hopefully, like me, you get 4 out of 4 or 100%. You ought to keep trying until you get 100%, guys. The law of sines is one of the things that, it's like Pythagorean theorem. You should be able to do it almost automatically. Okay? See you around.